Hello everyone and welcome to today's webinar, which is brought to you by Bettersize Instruments in partnership with EZO Network.
The title of my talk is also a brief description of the vision of my research group at Rice University, a material science-based and data-driven approach towards sustainable and durable infrastructure. So the goal of our research is to help tackle what I believe is one of the greatest societal challenges of the 21st century. That is how to meet our society's growing demands for buildings, resources, and energy, while at the same time minimizing the associated impact of these on our environment and climate. Now, in summary, this study has shown that AI-driven mixed optimization has significant potential to reduce both the cost and the carbon emissions of concrete mix design. This also includes incorporating more domain knowledge into the model so as to further enhance the reliability and robustness. Now, this includes particle size, distribution, and density information of the raw material. Now, what I'm going to focus on is three industrial waste materials, which is blast furnace slag, a byproduct from steel production, coal flash, a byproduct from coal-fired power plants, and volcanic ash from volcanic activities. Now, overall, these low CO2 waste materials can be utilized for concrete productions mainly in two different ways. On the one hand, as you can see on the top, we can utilize them as a supplementary cementitious material to partially replace Portland cement so that we can lower its carbon emission. Now, firstly, here is the typical atomic structure generated for a typical slag, which is an industrial byproduct from steel production. And based on these structures, I have calculated the X-ray and neutron scattering data and compared them with the corresponding experimental data. As you can see, there are good agreements for both the X-ray total scattering data on the left and neutron scattering data on the right.
To refresh our memory, the size of cement has long been related to its performance, thanks to the hydration and hardening process. We all agree PSD is a key factor, but how can we control it? In the cement industry, the most widely accepted method is to control grinding processes. The grinding process is like a subtle balance of energy input and product outcome. When every second counts for the grinding processes, unsaturated grinding like test 1 and overgrinding like test 3 are both a waste of materials, energy, and time. We are thrilled to introduce the Bettersize S3 Plus particle size and shape analyzer. It is a two-in-one system combining LD technology with image analysis technology. Thus, we can utilize both methods to best understand the size and also shape distribution of particles. To help better utilize the unique design of Bettersize S3 Plus and to achieve the best performance, to do the measurements more easily, we provided two dispersion units and one optional auto sampler. Here is a real-world demonstration of how the Bettersizer S3 Plus helps with cement R&D and quality control. Among definitions of density of powder materials, true density is the density of the solid particle itself, with all the pores and air spaces excluded. The traditional Le Chatelier flex method on the left is slow, taking up an hour per sample. It's a completely manual process that uses hazardous, flammable liquids, which introduces safety concerns and creates expensive waste. In contrast, gas spigometry, or gas displacement method shown on the right, is a major leap forward. The measurement can be done automatically and incredibly fast, giving you a highly accurate results in just 2 to 3 minutes.
The question is, you mentioned particle size in your slides, but didn't elaborate on it. Could you share more about how particle size affects each of your studies?
is a key raw material property that can strongly influence the engineering performance of the final products. Now, the basic idea is that smaller particles, right? So they have more surface area. These finer particles, more surface area, which means they can react more quickly, more reaction sites, and faster reaction then impact not only the early edge property, but also workability, setting time, and also the long-term strength development and durability. So this is why in the industry, particle size are usually carefully monitored.